Okay, last example, and it's a little bit of a complicated trig question. So how many different ways can we do this question? So I can't just rely on that bypass rule where it was like sine kx. I can't rely on that. I'm going to have to go with my substitution rule. Sorry, I'm going to say this is method 1. Okay, method 1. What could I do? Well, I could let u equal sine x. Okay, so let's see what happens if I do that. What would be the derivative of sine? So du dx, the derivative, not antiderivative, derivative of sine is cos. And when I rearrange that, I would have that dx is equal to du on cos. And then I could substitute in. So I would have the integral of sine x, which is being represented as u, cos x, and then dx would get replaced with du on cos x. And then yay for us, the cos x cancels, and I'm left with integrating u du, which is equal to, so if you add 1 to 1, you get 2 over 2 plus c, which then u for us this time around was sine x. So this is equal to 1/2 sine x squared. So I could put my little 2 in there, plus c. So that was one possibility. All right, let's try it the other way. What if, method 2. What if I said let u equal to cos x this time? What would happen? Would I get a similar answer? Would I get the same answer? Let's find out. So I'm going to take the derivative. Remember, the derivative of cos is negative sine. When I rearrange, I get dx is equal to du on negative sine x. And then I'm going to do my substitution. So therefore, I would get sine x multiplied by, this time I said cos was u. And then I would have du on negative sine x. And this time around, the signs will cancel. I do have that negative, so let's make sure we remember there's a negative u du that I'm going to be integrating this time. And so I will get negative 1/2 u squared plus c, which is equal to negative 1/2 cos squared x plus c. So not quite exactly the same. That's okay. Let's see, is there any other methods that we could do? And then we'll look at the 3 answers together, because there actually is one more method. I kind of cheated by saying, is there any other methods? Okay, so the third option, method number 3, yeah, I'm going to scroll. So method number 3 would be to use an identity. Okay, so rather than doing substitution, so we're integrating sine x, cos x in terms of x. So there's the dx. So instead of using the substitution rule, I'm going to see, is there an identity that I could use? So what do I know? I know that sine 2x is equal to 2 sine x cos x, but I just have sine x cos x. I have no 2 in the front. So if I divided the 2 to the other side of the identity, then I would get a match. Okay, so this would be 1/2 sine 2x is equal to sine x cos x. Okay, so I'm going to replace that sine x cos x with 1/2 sine 2x. I'm going to put the half right out front because I now know that constants are allowed to go out in front of my integral sign. And I've reduced it now to just sine 2x dx. Now I can actually use my little cheater rule, the 1 on k rule. instead of the substitution rule. So this would be 1/2 equal to 1/2. So what is the antiderivative of sine 2x? The antiderivative is negative cos of the same argument divided by the coefficient on x of the argument. So that's that k value, and then plus c. So this is equal to negative 1/4 cos 2x plus c. And you're like, great, we got 3 different answers for the same integral. So let's see if we can compare those 3 answers. In the first one, we got the answer 1/2 sine squared x plus c. In the second one, we got negative 1/2 cos squared x plus c. And then the third one is right here for us to see, negative 1/4 cos 2x plus c. So they all have this plus c. That's good. That's encouraging. Could we make them all match somehow? Okay, so what if we looked at our identities? And so let's look at that for a second and see if we can get these guys to match a little better. So remember, sine squared x plus cos squared x is equal to 1. So that would mean that sine squared x is equal to 1 minus cos squared x. So let's substitute that in for my sine squared in this first one. So I would now have 1/2 multiplied by 1 minus cos squared x plus c. Multiply that out, I get 1/2 minus 1/2 cos squared x plus c. And then I'm just going to rearrange that a little bit. So negative 1/2 cos squared x plus 1/2 plus c. So when I compare that to the middle answer, I have a match on my negative 1/2 cos squared x, and then there's plus some constant on the end. Well, that actually works because here's my match of negative 1/2 cos squared x, and this guy is some constant. So remember, these are just family of functions. That just represents a constant. So this, in fact, would work. And then let's look, could we do the same thing on the last function? Okay, so I'm going to think about an identity for cos 2x. So let's look on our formula sheet. And remember that cos 2x has 3 choices, but I'm trying to make a match with cos squared x, this guy in the middle. So I'm going to choose the one that's 2 cos squared x minus 1 as my choice out of those 3. So this is equal to negative 1/4. Cos 2x is going to get replaced with 2 cos squared x minus 1. And then I have my plus c. And when I multiply this out, I get negative 1/4 times 2, which is negative 1/2 cos squared x plus 1/4 plus c. And again, we see we've got our match on the negative 1/2 cos squared x. That matches. And then I've got some constant on the end. So in fact, we managed to find an answer in all 3 methods that is similar. That's the same. And remember that we are just finding a family of functions. The process, okay, let's write this out. The process of anti-differentiation or integration, which it would be called in university, this process of anti-differentiation does not determine a unique function. Okay? It rather finds, it finds a family of functions, each differing from the others by a constant. Okay, so that's essentially what we did in this last example, is we found 3 different functions, all differing by a constant. Okay, so there were 3 different answers there. All right, so I am going to come back and do those last 2 examples in the final video in case you're interested or you want to come back and look at it at another time about the logs. Again, the logs and the exponential functions from chapter 8, we are not covering. They are actually considered extra by Alberta Ed. They're one of the alternative choices. And so that's the reason why we chose not to do chapter 8 for this particular semester, just given our time constraints. But if you're interested, go ahead and come back and watch them in the last video. There's just 2 of them. Again, this comes out of knowing what the derivatives would have been from chapter 8, and which we didn't cover, but I do plan to cover chapter 8. I'm just going to do it after classes end June 9th. So those the last couple weeks of June, where we would normally have been writing final exams, we're going to then teach chapter 8 then. Okay, so if you're interested, come back now and watch it, or watch it in June, or don't worry about it. Okay, it's not going to be tested for you guys this semester. All right, I'll see you back for 9.2.